Text, I am CSE. Kyle Johnson, Robotics. Paul G. Allen School of Computer Science and Engineering.
My name is Kyle Johnson. I'm a PhD student in computer science and engineering at the Allen School, and my advisor is Vikram Iyer.
Kyle walks into a large lab space filled with various equipment, computer stations, microscopes, a whiteboard with diagrams. He sits down in front of a microscope and operates on a tiny component. Uses two corded prongs to work on a circuit board in a petri dish.
When I was going into college, I was wanting to get into something that would allow me to actually impact multiple fields. I'm able to work with mechanical engineers, electrical engineers, other computer scientists, and even like chemical and biological engineering students. What drew me into robotics was just how interesting it is to be able to make something that can move on its own. A lot of the times the way I look at our little bug-sized robots is that we're creating life. We're creating something that can actually go out and seek out its own energy source, something that can go and actually be able to move itself to different areas and environments it can explore, and it has these behaviors like a real insect would have. And the idea with the microflyer was to take advantage of these small electronics that we've been able to fabricate in the lab in order to control how it dispersed on the way down.
He walks over to a display with a poster filled with diagrams and a set of small plastic containers and a glass case.
So our origami microflyers here were actually inspired by leaves like maple leaves that have similar falling behavior.
A video slowed to 0.1 times shows falling leaves. Text, tumbling state. He compares a robot in his hand to an actual maple leaf, showing the similar layout.
And then even the root structure of the faces of our origami were inspired by the roots that you can see going to the tips of leaves. So these origami microflyers are considered battery-free because we have these 4 solar cells on the back that actually charge the microcontroller. The microcontroller here actually controls all the sensors that are on board and sending that off, as well as the actuation or the transition between the 2 states that the structure goes into. So in one state, it's flat and it tumbles really far away from the original drop location.
A slowed video shows the robot drifting down in a tumbling state. A fan blows from the side causing the robot to fall far away from where it was dropped.
But we can control the transition without having a battery, all while it's in the air.
Presses into the center to transform the shape. The corners point upward. Another slowed video shows the robot falling down in a controlled, straight descent. Stable state. A fan blows from the side but the robot falls straight down from where it was dropped.
And in this state, it's the stable state or transition state, and it actually falls like straight down.
A comparison video shows the stable state and tumbling state inside contained tubes with wind speed of 1.83 meters per second. In the stable state it floats near the top, and in the tumbling state it bounces down the tube from side to side.
And controlling the 2 states allows us to control how far away these devices float in the wind from the drop location.
He works on a computer. A video shows him operating on a microscopic circuit board. And he looks through the microscope.
These things could be used for environmental monitoring, anything from climate change to even monitoring different insects, and help us learn more about how we can make different farmlands and things more efficient.
His shirt reads, Avela, a vision for engineering, literacy, and access, in multicolored letters with illustrations of a rocket ship, gears, an atomic diagram, arithmetic symbols, and a cluster of hands making fists in the stars.
I'm also the co-founder of Avela, a vision for engineering, literacy, and access. Avela targets underserved youth in the Seattle area, predominantly Black, Hispanic, and Latino youth.
He presents a scientific diagram to children on a projection screen in a classroom. Later does a craft project with the kids.
The Allen School has actually helped fund the Africatown Community Land Trust. They have the William Gross Community Center, which is like a local makerspace down near the Central District, where we've been going and teaching classes each quarter. And hopefully together we can help impact the next generation of K through 14 students who are going to make major waves in these fields in years to come. My name is Kyle Johnson and I am CSE.
Text, Paul G. Allen School of Computer Science and Engineering. cs.washington.edu. Copyright Paul G. Allen School of Computer Science and Engineering, University of Washington, 2023.